Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Thank you for joining us on today's Security Boulevard webinar, How AI and Shift Left Can Help Transform Your Enterprise Testing, brought to you by digital.ai. Before we get started, I just have a few housekeeping items I need to go over with you. First, please remember that this event is being recorded, so if you miss any or all of it, you'll be able to go back and watch it. We are taking questions from the audience throughout, so make sure you submit your questions using the Q&A tab there on your console. We will try and get to as many as possible at the end of the event. All right, with that, I am pleased to introduce to you Juan Lugo, the Product Marketing Manager at digital.ai, and Guy Ariely, the QA CTO of Continuous Testing, also at Digital.ai. Gentlemen, I'm going to put myself on mute, turn my camera off, and let you get right into it.
Awesome. Thank you so much for the introduction. I appreciate it. All right. Hi, everyone. And like she said, welcome to How AI and Shift Left Can Help transform your enterprise testing. Let's go dive right into it. As she said, we have Guy Ariely, the QA CTO for Continuous Testing, and myself, Product Marketing Manager for Digital.ai. All right. Okay, so before we discuss where we're headed, let's briefly cover how Shift Left has developed over the years and why it's one of the biggest buzzwords in mobile and web app development. So, quote unquote, the age of the customer, where customer experience is what makes or breaks organizations, and digital experiences are at the forefront of the customer experience itself. And so web and mobile applications are expected to provide consistent customer experience across all channels at any time and anywhere. And so with that, we have dev teams that are under vast amounts of pressure to constantly, ship new web and mobile apps within shorter timeframes, but also without compromising the quality of the apps themselves. And so as software delivery cycles become shorter and shorter as they have over time, software development underwent a paradigm shift, if you may. And several new development methodologies and processes have been introduced with that, all with the purpose of speeding up the development cycle, of which continuous integration, agile, DevOps, and continuous delivery are the most notable. There is a common thread to these new practices, a trend, if you may, which is developing in small increments, committing code often, and fostering communication amongst working groups, all designed to enable change and early validation of software. Okay, so as you all can imagine, by now the demand for faster product releases, optimal app performance, and ultimately happy customers are the top priorities for companies looking to differentiate themselves in this rapidly changing and highly competitive market that we are in. With that, we have IT leaders striving to adopt new modern testing approaches such as continuous automated testing that can help companies not only keep pace with modern delivery, but also ensure that they are providing an optimal digital experience that drives the value for the businesses and the customers. And ultimately, what it boils down to is that testing early, better, and faster is the new imperative for organizations. So as continuous delivery and integration accelerates release velocity, manual testing quickly becomes a bottleneck and creates inefficiencies in the value stream, since it's slow, it's expensive, and it's resource intensive. Another common issue is when testing occurs at the end of the life cycle of the software development process. This is typically where developers receive test results, and it's also when the defects are significantly more time-consuming and difficult to fix, which can delay the time to market. It can drive up the costs and increase the business risks of the software candidates. And so we have companies increasingly taking a shift left approach where testing starts earlier and happens continually throughout the delivery process using automated approaches. This testing strategy enables faster feedback loops, so developers and testers can fix defects when they are easiest, fastest, and cheapest to fix. With that, inadequate testing environments hinder developer and tester productivity as well as efficiency. So as fragmented device models or OS versions and network conditions expand across multiple test surfaces, existing testing environments lack the scalability and extensive functionality needed to ensure proper test coverage. And as QA and dev teams become more and more distributed, companies need an easier way for these geographically dispersed teams to collaborate on testing. So the main takeaway here is that while most companies are still missing their deadlines as the demand increases, and this is because they are still manually testing the code, which requires testing windows. Therefore creating bottlenecks and the tests that need to be executed, which never really coincides with the availability of QA teams and dev teams. This resulting in endless backlogs of test performance. Okay, so here we have 5 common challenges experienced by enterprise utilizing the traditional testing solution. First off, we have the vast shift towards work from home or remote teams, which has resulted in strained collaboration and communication, as well as extended feedback loops across the entire SDLC or systems development lifecycle, from R&D to testing and QA teams. So as an example, you can no longer go to someone's desk and confirm a testing window to a tight deadline release, meaning that the organization must figure out a way to adapt quickly to meet both the demands of the organization, but also to improve the old processes. And so QA and testing teams are faced with the challenge of balancing process execution and new initiatives. And as working groups adapt to change within their processes, enterprises are focused on business continuity and accelerating new digital initiatives. With that, manual testing, which is not effective for modern enterprises on its own, as the demand for continuous quality increases, and this has certainly been the case in the last few years, especially recently with the global events. So as you all can imagine, delayed testing feedback results in significant setbacks with product deployments. And this is due to the development teams receiving the results later in the software development process and delivery process, rather than earlier and with more frequency. And so distributed teams are faced with delivery bottlenecks as they collaborate on testing while setting disjointed delivery timelines as well. Is there anything else here, Guy, that you think perhaps we could add to the list or something significant that pops out at you?
Sure. So yeah, one thing everyone agrees today is that manual testing cannot be a significant part of your testing strategy. You cannot rely on manual testing, and what you see is that the majority of the effort QA organization are, and this is maybe the unresolved part in this puzzle, is how to automate your test, how to build a stable automation test environment, and this has been the challenge I think in the last 10 years, and we see it becoming more and more important.
Right. Yeah, definitely, especially in recent the last couple of years, especially. All right. So. Okay, so increasing the release velocity and improving the customer experience are the top priorities for companies, as we mentioned, right? As they're looking to differentiate themselves in this market that we're in. So we have a problem that rises here when testing occurs at the end of the software lifecycle, as we've been harping on already, just in these few slides. And this is, again, typically because that's where developers are receiving the test results, and this is when the defects are significantly more time-consuming and costly to organizations. So what are the implications for organizations addressing bugs post-release, right? So we have financial setbacks, we have brand damage, customer retention, and in some cases we have regulatory compliance issues if there's a bug or a leakage resulting from having the bugs in the post-release. And so we have organizations increasingly taking this shift left approach, as we've been saying, in order to automate their testing and also to mitigate all these issues here. And more significantly here on the right-hand side, we have the cost itself. So it's one thing to see on the left-hand side, like, okay, these are the things that, or the factors that we have to consider if we're going to be using a more traditional form of testing, using manual testing, whatever the case is, post-release. But then you also have to look at the figures, and I think that speaks for itself, where according to our source here, on average, when you address these issues earlier in the SDLC, you're looking at a range of 25 to 80 to fix per each issue. Now, look at the price now when you look post-release. When these issues are addressed post-release, it increases exponentially. So it's definitely something that you have to factor in and consider. And then along with the exponential growth there in cost, we have to consider also the customer retention and the brand damage, as you see here on the left-hand side, because those are also going to be the kind of follow-up in the aftermath. Going back here, is there anything else here, Guy, that you think organizations need to consider, especially with addressing issues post-release?
Yeah, so what we are seeing here is how cost is distributed depend on the level the bug is identifying, and obviously as many bugs as you find as early in your process, that your entire process is become much more efficient. If you know to narrow the responsible for the change, this is also a huge value, and for doing that you do need to have a mechanism of pull request, where every developer, for every change every developer is making, a new build will be generated and it will be tested independently, and this is also something that reduces the costs dramatically.
That's interesting. Okay, so along with that, let's take a kind of a deeper dive here and look more specifically and discuss the challenges and benefits to organizations that are, taking the shift left approach. So first and foremost, oftentimes teams are left with the daunting task of reworking their legacy code in order to be able to shift left effectively. We have teams running complex projects that will encounter shift left implementation issues if they haven't deployed a test automated solution. We have varying levels of coding knowledge or capabilities between R&D and QA teams, which causes not only frustration amongst the teams, but also delays in the SDLC. And the fact that it's highly dependent on the team culture. This is something we're going to elaborate on a little bit more here in a minute, but specifically around unit testing, which is dictated by the way that these tasks are communicated and passed on to key individuals with the necessary technological know-how. However, organizations that successfully implement this shift left and testing earlier in the SDLC experience increase organizational efficiency. Their productivity as a team goes up. It speeds up the release cycles and increases the bug mitigation. So in other words, you're able to kind of catch those bugs pre-deployment rather than after these applications are released to the public. Okay, so the main point here is that shift left is more than a simple change in timing. Shift left implies a shift in mindset, a shift in responsibility, as well as a shift in organizational processes and structures. So this can be applied to smaller teams as well as the organization at large, right? It is critical for organizational leaders to establish the processes, but it's also a cultural shift that needs to be nurtured from the top down. And it's doing so for these 4 specific areas that require attention here. So we have roles and responsibilities, skill sets, processes, infrastructure, and tools. Okay, so while companies may differ in how far left they progress on the shift left scale, they still have several things that are in common here. For instance, they focus on test automation, even in the earlier unit testing stage. They experience more collaboration and resource sharing between dev teams and testing teams, and they tend to be extremely quality focused throughout the development lifecycle, including test-focused design methodologies such as testing-driven designs. Guy, can you add a little color here? You've had a lot of experience here, decades more than me in this industry, and you've probably seen the natural progression of this here to where we are today.
Yeah, and I think it also highlights one of the main challenges in shifting left, because shifting left was born in a very technical organization like Facebook, Google, Amazon, and others. And more than the fact that those organizations are very technical, those organizations has a nearly unlimited engineering force. Right. So if they want to recruit, if they want to onboard, they have capabilities that no other enterprises has in their capability to recruit and onboard technical people. And Shift Left was born in an environment where you could tell an R&D organization, you are responsible for everything. You will do the R&D, and you will do the unit testing, and you will do the testing itself, and you are the last gate. Once you approve it, it is going to production. So take a full responsibility and ownership for your code and quality, and this is up to you. You're not going to get any service like testing service that will come after the release. Whatever you will be released is going to go to production.
So pretty much what I'm getting from that, in other words, is like we have these larger corporations that perhaps didn't consider themselves SaaS offerings or more technical organizations, but now they're finding that they are in fact a SaaS. They do have a SaaS offering, and because of the progress we've made with Shift Left and testing automation, it's not necessarily a problem for them, because we have solutions that can address and maybe bridge the gap there technologically, correct?
Yeah, absolutely.
All right. Okay, so let's look at this table here, which shows the effect Shift Left has on different roles and what they can do to get ready for the changes. So just as we were discussing in the previous slide here, we had some more technical organizations that were able to adopt Shift Left. Not easily, but a lot smoother than more of the legacy or organizations that we have. So let's look at some of these different personas here. So first off, we have the dev tester, and these folks typically don't like testing, but if they have to, they automate. They would rather do something, through programming in their own IDE or integrated development environment. This requires no recording nor replay. And if they want to, they can ensure a smooth transition. There are two actionable items that they can do to help with this. First off, learning automation principles and writing the code that can be easily automated, as well as learning about QA methodologies in general. And so then we have the technical testers who understand code but don't necessarily program themselves. They use scripting languages that fluently, and they're able to use scriptless as well, and record and replay for automation. In this case, the suggestion is to decide your direction, whether you want to be a domain expert or automation engineer. To be a domain expert, you have to become familiar with the product business drivers, communicate frequently with developers, and develop your soft skills as well to properly articulate your messages. And if you would like to do, the latter, you become a automation engineer. You start learning a coding language, but you don't have to necessarily become an expert programmer. But that's definitely a path you want to at least embark in. And finally, we have business testers who are limited technically, and when it comes to scripting or with coding skills in particular. And so they prefer fully codeless tools for testing. Now, for this group, they need to focus on automation as well, but more specifically with low code or no code testing. And we're going to talk a little bit about that here in a minute. So this aligns with what we discussed earlier in terms of the need for a cultural shift along the change in processes. In addition to the new practices, you also need a modern technology foundation. So overall, better technology will help all the testing personas we described in this previous slide: the dev tester, the technical tester, and the business tester. Along with that, we have AI augmented testers, specifically the business and technical testers, which tend to lean more on the manual testing. And finally, the low code, no code testing, which can be a game changer for organizations gearing up to scale their reach. Okay. So with that, our QA CTO, Gabriele, will cover infusion of AI continuous testing.
Right. So what I'm going to show you, and this is a very unique capability, is something that involves Codeless with model-based testing to enable you a very easy way to create functional tests. Now, Codeless has been with us for many years, and you can see here a few examples of Codeless offering in the field of QA and in other fields that were here with us for more than 20 years. And obviously, they didn't deliver what was, the expectation. So in many cases, they were very nice during the demo, but when they had to scale up to the complex of a real project, it really introduced a lot of challenges. So my statement here is that there is a difference between codeless and code visualization. And in order to make something codeless, you really need to reduce the complexity. It's not enough to show lines of code in a form of Excel or any other nice user interface. So let's go to the next slide. Okay, so why the old generation of code visualization failed? So first of all, they were not codeless, they were code visualization. They did not reduce the complexity, they just translate it into something that some can state that it's easier to consume. It just was a different way to describe the same logic, but if your logic was complex, then it became even harder to represent it in those user interfaces, because there is a reason why IDE has all of those capabilities. IDEs are the perfect tools for presenting and maintaining complex code. And what it also creates is a huge gap between what the stakeholder think that the tool can do and what it can do in action. So whenever and usually during the demo, there was a relatively simple problem that was presented, and it was solved very easily, and all of the stakeholders were very excited. Okay, now it will be very easy to automate. In reality, there were a huge gap between the expectation and what could achieve in action. And the last and most hard problem is that it didn't really scale, and it didn't scale because when you describe code, you need coding tool, you need to design your project, you need to build it right into building block, you need to refactor it, and a lot of things that the team wasn't trained to do, and this creates a scalability problem. Okay, let's go to the next. Okay, next we have also a relatively old concept, which is the model-based testing. The idea behind the model-based testing is that you're not writing tests directly to your product, but you build a model that describes your product behavior, and then the tests are being generated autonomously. So here we can see the flow. We have the part where we are creating the model, then we are generating tests, then we execute the test on the live application, and then improving the model even more, and generating more tests, and so on and so on. The challenge in model-based testing was that creating this model was very complex task. So we had to map every action and every button, and adjust it into the model and say, okay, this. So every line within the model represents some kind of action, and to build a relatively big model require a lot of work from the user, and most of the challenge in model-based testing was around that. So let's go to the next slide, where we can touch on the digital.ai approach to model-based testing with the help of AI to help us build a model. So what we did is we have created and I'm going to demonstrate that in a few minutes, the capability to do fully autonomous process that build this model. We are using different technologies. You will be able to see how we leverage bots that will map the application and explore it. Once you have built this model, based on that, we can build or create the test. So we are first exploring the app, creating the model, generating the test, executing them, and then doing this cycle over whenever we have a new version of the application. So I think it's a good time for a demo. Okay, great. Let me share my screen. Okay, so I hope everyone can see my screen. Just a few words about the digital AI mobile and web platform. Here you can see I'm using a platform that is distributed across different region and geographies, so I can select devices from Australia, Singapore, UK, Germany, the EU, and the US. Here I have a few devices that I'm going to use them for my demo. And now what we can do is just open one of those devices so we can interact with the device. After a few seconds, we can start interacting with the device. So here, let me just remove that. So we can perform any operation that a user can perform on the device, clicking on any button. We have different behavior and sensor mocking capability. I'm not going to go into that. What I'm going to show you is that the application that we are going to test. And here you can see I can open my application management, and I can go and launch this application on the device. And here you can see a login screen. If I will click on this login button, I will get this error. And if I will click on close, you can see that the dialog was closed. We have a username and password that we can put in. The username and the password is a company. And once we logged into the application, you can see that we have different options. The application split into different tasks that we can perform. So relatively straightforward, simple application. I'm going to end this session, release this device, so it will be back in my device group. And now we're going to see how we can do the codeless bot magic. So what I'm going to do here is I'm going to create a new project. Let's call it E7 demo. And I'm going to select this same application to be used in that project. So each project will have its own application. And what we are going to trigger now is an exploration. So I can select the amount of devices I want for the exploration and the type of devices. This is an Android application, so I'm going to use just Android application, and I'm going to trigger this exploration. So what will happen in the background is that out of my pool of devices, we're going to select 3 devices to be used, and those devices will take part in the exploration. What they will do, they will start by installing the application, launching it on the device, and then start touching the application. Based on what it will find, it will create the model we are referring to. So here you can see the 3 devices that got selected, and if we will go to the execution tab, we will be able to see all of those 3 devices, and you will be able to see that the application is being installed on all of those devices, and it is going to launch the application on all of those devices, and we will start to see the process of mapping the application. Now, let me go back and show you what we currently know about the application. And this is what we are going to see the model. The best way to see the model itself is by opening the graph. This is the easiest representation of our model. And if I will refresh our model, this is what we currently know on our application. We know that there is a login screen, and we know that whenever we click on the login button, we will get this error dialog. If we will continue to refresh, we now also know that if in this error dialog, if we will click on close, we will be back in the login screen. So very simple. So far, so good. This model is, as you can see, is a very simple model. It is important to notice that we didn't need to do anything. It was learn autonomously. And what you can also see is that we identify that there is nothing else we can do at this moment. So the exploration ended at this stage. And what we did is that the machine identified what we call a gate. And we can see it here. This is the gate that was identified. A gate is anything that block the bots from exploring the application. And let's click here on unlock the gate. And here you can see this is the screen that's blocking us. And it makes sense. This is the username password screen that we saw earlier. And we can use Appium code to pass this gate, or we can use a very simple format that called form to do that. Let's use that. I'm going to use the suggestion here, and you can see that most of the work was done for me. All I need to do is add the values for the username and the value for the password. What it says here is in the username put company, in the password put company, and then click on the login button. I'm going to even do something nicer here. I'm going to say, okay, this is the username, and I'm going to use a company as my default. And here, this is my password. I'm going to use company as well as the default. So we will be able to parameterize the values here. And I've just saved this gate. So now this gate got unlocked. And we can go into our exploration, and we can continue our exploration. So we can see the username and password. We will continue to use 3 devices, and our exploration is alive again. Then a new set of bots or devices will be triggered, and we will be able to see this entire process continue. The difference now is that we unlock the gate, so the bots will be able to log in into the application and to continue to map the application and build and extend this model. As this process happens in the background, we will be able to see it here very shortly. What I'm going to do in the meantime is, based on this model, and this is the current state of the model, I'm going to go and generate a few tests. So here you can say, it says to me, based on this model, we can generate 2 tests. And I'm going to do that. And here you can see the 2 tests that were generated, and they are very simple tests. You can see it by their name. It says navigate to the login screen, click on the login button, and verify that the alert dialog open. And the second, navigate to the alert dialog, click on the close button, and verify that we are in the login screen. I'm just going to execute those tests in the background, only because I can. And I'm going to go and open one of those tests for editing. So this is the navigate. It says navigate to the alert dialog, click on this close button, and verify that we're in the login screen. So this is a fully valid test. This is our where the tests become codeless, where I can add more steps, and we will touch on the codeless part in a few seconds. As we speak, we can see that the exploration is still running. Let's see how the application mapping is progressing. And here we can see that we currently starting to explore the application. So here we were able to do the login part, and here you can see different part of the application are getting revealed. And as we will wait, and more tasks will get finished, and we can refresh our model and see that we are learning more and more about the application under test, until we will fully map this application and we will have a full model. It takes a few minutes. I don't want to wait this entire time. This is the reason I'm just going and generating tests as during the mapping process. And here you can see that we can now, based on the new model, generate 9 more tests. So this is nice because we can see that we're executing the test we're passing, the 2 tests, but now we have much more tests, and we can even go and trigger the new test. So as we are mapping the application and generating tests, we can just go and execute them. You can see that we are identifying new gates. And by doing that, we are generating fully valid tests. So let's go and see, one more example of how the Codeless look like. So here it says navigate to this screen, and then click on the advanced action, and then verify that we are in the advanced action screen. Here, usually what I will do is maybe add more verification. The important is you will never see here the full login process. It will not say how to navigate into this screen, and this is why this is how we reduce the complexity of our testing, just by relying on the model. Here, all we are saying is based on the model, just navigate to the screen. So if the model change, we can change the entire test without changing the code of the test. It will automatically adapt to any new model.
Wow. So you're automating the test there. You're automating it, and then you're also providing the visibility for the users as well.
Yeah, absolutely. So the user, usually what they will do, they will generate a few tens of tests in just a few minutes of working with this platform, and then based on that, they can continue to expand their flows and generate more tests. Here you can see the mapping process is going on, and we're in the final stages of mapping the application, and we have now a relatively nice view on the application. What you need to understand is that there are several use cases that this model is being used for. One of them is for manual tester, just for navigating in the application. A marketing team that want to understand the application flow. We have an automation team that can rely on this model in their Appium test just to perform the navigation. We have what you've seen here, smoke testing, generating smoke testing in a few minutes. And we have also our capability to create a user experience score for the application. So whenever you change the application, we can generate a new score for your application, and you can verify that the changes that you are introducing into your application doesn't harm your user experience. We are also identifying anomalies in the performance and the visual anomalies, so it can be very helpful for your automation team. And as you can see, it's nearly effortless to do that. So I think that's it from the demo perspective. Let me stop my sharing, and we can continue.
Thank you, Guy. Yeah,
with the presentation.
So as Guy was saying here, he went over some of the benefits there to utilizing something, a solution that has more visibility for folks here. But let's summarize how the organization can benefit through optimizing the customer experience here with shorter test cycles, and faster releases, and lower risks. So first off, we have the increase in efficiency. So a greater efficiency and immediate test feedback, which enables the team to find and fix the defects earlier in the the development of the life cycle, right? When they are easiest, again, when they're fastest and cheapest to fix. As you know, that has been the common trend here in our presentation. And as you saw in the demonstration just now, when you have full visibility of the application itself, not only is it good to have access into what exactly the users are going to be seeing, but it also enables you to map out all paths of execution, and with that, all the vulnerabilities that lie within them, right? As you move from one screen to the next. And so accelerating test cycles enables you to execute larger scale tests in parallel on multiple browsers and multiple devices, as Guy demonstrated, all from one platform, so that you can reduce the cost of testing and improving the reusability of these test cases, which is also great for reducing the time lost while you're managing multiple disjointed systems. So again, tying into the automation part of it, right, which is also going to help the business testers, which are looking for low code, no code, or test automation in general. And then there's accelerating your agility, which consists of increasing the release velocity by testing continuously throughout the development process using automated approaches. This empowers less technical users, like the business testers, to create and run tests in the Codeless testing environment, and to alleviate the burden on the developers and the QA teams, the QA engineers. And so developers can easily create accurate tests right from their own IDEs without wasting any time between context switching. And moving on, we have reduced risks, which can predict users' reactions to new releases. In order to avoid the customer experience issues that are expected post-release, and ensure that the software release candidates are within the acceptable business risks for analytics. Okay, so just to provide a little more context here, we have a case study with a customer that I think truly showcases the value in leveraging the right continuous testing solution. Okay, so let's look at the challenges. So we have United Airlines, which aim to test more than 20 B2B and B2C apps on devices running iOS and Android. So United had a massive development operation with more than 250 applications and more than 160 million users. They were conducting app-focused testing, including load and test automation, and it also had recently incorporated continuous integration and continuous testing. And so, as you can imagine, with this level of demand that United experiences, they recognize the need for a modernized approach and the need to become more responsive and proactive with their test operations. So the United QA team began using Digital.ai SaaS offering that we just demonstrated here in order to run hundreds of tests daily across more than 100 real iOS and Android devices, which of all were hosted in our data centers across the globe. As a result, within the first 9 months of implementation, United conducted more than 2 million automated and manual tests, leading them to save more than $24 million in test automation. Essentially transforming the test operations from slow, siloed, and reactive QA processes to a fully automated continuous testing environment that operates around the clock. This improved their collaborations across their distributed teams by enabling their remote access to their Chicago-based mobile device lab. And just to kind of bring things back in full circle here and wrap things up, this ties into the Digital.ai approach, which entails leveraging AI along with shift left in order to create a truly intelligent platform that connects all software development and delivery efforts to business outcomes. The platform connects agile planning, software delivery, application security, and quality so that you can meet the increase in market demands. The goal here is to continue to provide business context throughout the entire value stream delivery. Okay, so let's go ahead and open up the floor to any questions we may have from the audience.
Fantastic. Thank you so much. All right, I think we've got time for a couple of these here. Let's start with this one. My organization is not as technical as, say, a Google or a Facebook. How can shift left work for my company or other companies like me?
Sure. So I think shift left is a valid strategy for any organization. What they need to, so first of all, there is the part where a culture change need to be done, educating the teams on unit testing and on taking the R&D, so giving the R&D team the responsibility of the product quality, and also adopting tools that can meet the skill set of the different team and workforce.
Okay. Let's see. How do you calculate the UX score in the bot solution?
Right. So yeah, I've mentioned the UX score that we can provide for your application, and I didn't mention how we calculate that. What you need to do is you need to map your application, and you need to say, these are the important tasks within my application. So if it is a banking app, maybe a money transfer between account will be valued as this in this level of importance, and other operation will be valued in different level of importance. Now, as we have a full visibility of the application, we know everything about your application. We know how many operations are required to perform any task. We know what is the speed of your application. We know the sizes of your element and buttons. So we can calculate and provide a full user experience score based on what you define that is the important task of your application. And obviously, any user experience changing your application can improve part of the flows and can to the better, and maybe can harm other parts of the flow. But in the end, the hard task is to optimize it to a level that the application has as high user experience score as possible.
Okay. Right, and then also having the visibility to do so, right, Guy? I mean, just in the demonstration alone, you demonstrated, there was one point that was really cool, where you show how you're able to automate the tests if you're coming more from a business context rather than a QA or engineering background. But then you also have the visibility into what's occurring within the application every time you take a step forward into a new screen, which again ties back into what you're saying there, because it helps them kind of mitigate those risks as much as possible.
Yeah, absolutely. So this is also touching on the shifting left and your team capability. We are trying to enable anyone in your team be an active part in the automation project in this shift left trend.
Right.
Okay. All right, I think we've got time for one more here. What is the difference between emulators and real devices?
Okay, sure. So the digital AI platforms support both emulator, simulator, and real devices. What we demonstrated here are real devices. Now, there is quite a big difference between the two platforms. When it's come to simulators from Apple, the application itself need to be compiled differently. So in mobile devices, it is compiled to a ARM processor, and in the case of simulators, it is being compiled into x86 technology, and it is going to be changes as Apple introduce a new Mac Mini with new processors, but this is the current situation. There are other problem and fragmentation with screen sizes, with in the case of Android, different manufacturers, different versions. So it's a common practice and a good one to test your application. When you are in the unit testing phase, it's fine to test your application on emulator and simulator, but before your application goes into production, it needs to be tested on all of the physical real devices in all of the versions, screen size, and manufacturer, and so on.
Right. Not to mention the geographic component there, the factor of if you're testing an application, let's say, for instance, the banking one that you were demonstrating there, what kind of compliances you have to adhere to. If the application is based in the UK, you have the GDPR in terms of Privacy Act. If you're in California, you have the CCPA, so on and so forth throughout the globe. So it's important not only to note that that you want to have that leverage geographically, but you also want to be able to understand from a performance standpoint what kind of factors are going to hinder your application. If, for instance, if you're somewhere in the Middle East, if you're in Africa and you have an application, you want to understand how is the user base in that location, that specific geographic location, going to interact with my application, and what are the implications that are going to be a result of either app protections you have in place or any other many contributing factors that can affect how the usability, the UX, right?
Absolutely.
Yeah.
All right.
And with that, Guy, actually, I wanted to also throw in there, how many data centers do we have globally? I believe it's 7, correct? And we have more than 2,000 real devices.
Right. So we in total we host I think that more than 10,000 mobile devices. Most of our environments are dedicated environment that are being used by huge enterprises. You can get devices in Australia, Singapore, in the Middle East, in Germany, in the UK, and we have 3 data centers in Canada and in the US. So, perfect. Yeah, it's.
And with that, also last point, I think it's very valuable to point is the fact that you could have a hybrid solution, right? Like you could have, you could have you could use emulators, but you could also have an on-prem solution and also use the cloud as well, right?
Yeah, so one of the new offering that we have enables you to build a hybrid solution where part of the devices are hosted in any of our data center around the globe, and other devices can be hosted on your premise. Usually for security reasons, there are different applications within your organization that can be only accessed from the local organization Wi-Fi. So some of the application will be tested with local devices and other will be tested with devices that hosted by digital AI.
Wow, cool.
All right. Well, thank you both so much. I think that's about all the time we have for Q&A today. If you submitted a question and we did not get to it, please rest assured we will send these on to Juan and Guy, and they will be able to answer any of those offline.
Awesome.
So, yeah.
Thank you for having us, guys. Appreciate it.
Yeah, you bet. Just a reminder to the audience that this session has been recorded. So if you missed any or all of it, you will be able to do so. We'll be sending an email with instructions for how to access the webinar on demand, or you can visit us at our website, and that will be there for you. Excuse me. All right. Well, thank you again, and thanks to the audience for your time. We hope to see you again soon. I'm Sharon Florence.
Thanks so much.
Yeah, signing off.